Are we all good? I just want to make sure before we start. Okay, audio's coming through.
Yep.
Okay, sounds good. Hey, good morning. My name is Zachary Trivet. I'm the library instructional technologist here at the Catawba Library. I just recently got hired in January over the digital learning lab that's upstairs. If you have not heard about the digital learning lab or have not used it, uh, I am not surprised. A lot of people tell me that they don't know it exists up there. Um, but we have lots of things, and I'll actually talk about this at the end, that go beyond 3D printing. We have VR headsets as well. We have a video studio. We have a Cricut maker if you want to do any of those crafting things, and we have laser engravers. But today we're going to be talking about 3D printing, and it's basically a very quick crash course for if you're really interested in it in terms of a hobby, a profession, something that you want to do for your business. We're going to talk about the ins and outs of that from beginning to end. What's the process? Talk about some 3D printers that are some examples, maintenance, things that you have to do that you necessarily probably didn't think of when it came to 3D modeling, and so forth. So we'll take some questions if you want to ask questions during the presentation, and I'll also leave some time at the end. If you would like, there are little 3D models there. Those are free for you to take. Some of them are little coins, some of them are little key change, and then there's some men there as well for you to be a stand up person, or the other one, which I really like, that's hanging on, which may be our emotional situation right now where we're just barely hanging on. We're just trying to get to the end of the semester, to the end of the year. So if you really connect with that person, of course, you can take one of those with you as well. There we go. Just so that was showing up as presentation mode on the screen. Yeah, I love it when it does that. So we'll start from the beginning. Basically, what is 3D printing for someone that's just completely new to what this concept is? It's basically additive manufacturing. We're starting from the ground level, adding plastic layer by layer until we get a finished product. What we used to have to do back in the day is we would have a stock, a piece of wood or metal, and we would have to like chisel that away, mill it down until we had something that was a finished product. So we have all of this, what we call waste, happening that we're just removing. It may not get recycled. Here with 3D printing, we're only going to use really what we need to build the model and the supports. It will make that from a model that you either make or you find, which we'll get into here in a minute. So some people that may be into 3D printing don't want to do all the background work and actually do the modeling. You may be able to find something that's online and be able to print it if you're just kind of a hobbyist and you want to print some cool things that you can have. So there's three main steps to 3D printing. Number one is the model. The first thing you can do is you can model it yourself. There are some modeling programs that are out there, such as Tinkercad, which is web based and free, Blender, which is free. You would have to download that to your computer, and then SketchUp, which is a blend of you either download it or you have it web based. I think that's through Google Chrome now, and those are also free for you to use. Tinkercad is the most introductory level one, and then you have Blender, which is very, very specific, very technical, and it has some animation aspects to you. So, kind of just to show you Tinkercad, if you've never seen it, I've got some things that I've done here. Like we had a workshop where we were showing off some of the 3D printers and we had 3D pins, but I wanted a way to get that off of the table. So I made this little a stand basically for the 3D print pin 3D printed that off, and I had that for my particular pop-up lab that was last week. We actually have a workshop on Tinkercad. If you're interested in learning about Tinkercad, that's next week, Tuesday at the same time, 11 o'clock here. Or if you want to see it on Twitch, you can do that as well. But what that looks like in terms of modeling, just to give you a very quick uh, show of this, that's your work plane. You can bring surfaces, images, models in here, and then you can manipulate them any way that you want to. And then how you actually get very technical and more advanced with this is that you take other shapes, lay them together, and then you can start subtracting and getting a little bit more specific with your models. And there is a lot of settings in here. Again, that is a whole separate conversation and a workshop that is next week. But that's to show you that this is accessible for everyone if you want to make very simple models. As an example, there is a class that's making tea mazes for cockroaches, and they've literally made walls and a maze, and the cockroach is either going to pick something that's on this side or on this side, some sort of stimulus, and they've made that, and they're just 3D printing. It's basically just walls and a floor. It's accessible for everybody. Back to this. Or, I love it when it does that. Or you can find things. You do not have to reinvent the wheel whatsoever. There may be some things that exist on there. Two of the biggest websites, Thingiverse, which is by MakerBot, which is this bot over here. I'm sorry you can't see it if you're online. You'll see it here in a minute. And then My Mini Factory. I'll pull that up as well. Thingiverse, you can just search for things. If it exists, you can download it. There are some stipulations, like some people put copyright on there that you cannot sell it. This is for personal use, so be mindful of that. I'll just type in the one that I use as a test print. Thin Man, which are the ones that are here. You can take those, find them. You can just look at what the file looks like. Chillaxin. And then you can go ahead and download those as what is called STL files, and then you would be able to put those into a printer. And then the other one is My Mini Factory, which is very geared towards very technical, specific models that you may not know how to model unless you are like really good at Blender. But you can download those, and some of them you may have to pay for, so just keep that in mind when you're looking at trying to find models that are online. Step 2 is once you have your model, you have made it, or you have purchased it or downloaded it from the internet, you're going to put it into a software. It's called a slicing software, and all that is it's going to take your model, your 3D model, and it's going to make instructions for the printer. It's got to figure out the amount of layers, where the print is going to go. So this is an example of a Cura software for a different 3D printer. You can see the model is here on what's called the print bed, which is what we'll talk about. And what it'll do is it'll make instructions for that to print it. We'll go into that more specifically a little bit later down this presentation. And then the last one is it will print it. It will take those instructions. It will lay plastic layer by layer until you have a finished model. And one thing that I want to make you aware of now and near the end is that depending on your print, it does not come out perfect. There may be some things that you have to do with it. For example, this for the people at home. Let me go to this real quick. Let me know if it switched to just chatting. Just a camera.
Oh, it's still, it just showed me.
Love that. It's not showing this?
No, it did.
Okay.
There it goes.
So for the people that are at home, it has to build supports for it to print things that are up in the air. So those pictures and those commercials that show you somebody just picking the model up off the print bed like it just finished, That is a very unrealistic thing that happens. This prints out nice and flexible pieces that are easy to break off. You may have to get some tweezers depending on how uh, detailed your item is, but depending on what it is, it may not come out perfect. I'm switching back to gameplay just in case. You let me know if it flips back. Yeah, it's delayed. It's good now. Okay, and for those people that are just interested in this as a hobby, there's a lot of things that you can do with this. This is really good for the medical field. They 3D print uh, prosthetics. They have organs for particular types of filament that are a little bit more flexible than this. You may not want to print out a heart valve out of this plastic and then just stick it in your body. There are more specific filaments that exist out there for that. Games and entertainment. This is really good for if anybody's interested in D&D. They like making those little characters. People that have cosplay things for there's anime, there's movies, little props. You can print those out and paint them. Space has been a really interesting one. It takes a lot of money to send things up into space. You can send a 3D printer up there, and this is what they've tested. And if they need a tool for a specific application, they will actually print it and then they can have it. So instead of having all the tools at your dispersal and you don't know if you're ever going to need them, they send a printer up there, print only what you need, and then you'll have it. And then there's food, which I find very interesting. Um,
It's not showing presentation.
why would it do that? We may have to show this in this particular mode.
Yeah, it seems like when you go to full screen presentation.
I'll show it like this if I have to.
Yeah.
I don't mind. Do y'all mind? Gosh, I hope not. So, talking about food is that it's really easy with chocolate because you can melt chocolate and you can make desserts. With again, you wouldn't want to put chocolate in a 3D printer like this. There's specific printers that will be able to do that and make desserts instead of you making them by hand. You can have them printed out and they'll cool kind of immediately. You can then serve them nice fancy restaurants. We'll keep it this way. So there's two types of printers that exist. The one that we're going to be specifically talking about, because it's what we have here at Catawba College in the Digital Learning Lab, is an FDM printer, which is a fused deposition modeling. It is filament. It takes plastic, it melts it into layers, and then the other one, which is really cool and it's for detailed work, stereolithography. It's SLA. It's resin based. So there's a vat of resin that sits in the bottom, and as you can see here on the right, it prints things upside down. So instead of the filament getting put on a print bed and going up, the print bed is going into the resin, and what happens is that there is light that shoots up to the print bed, cures that resin in layers, and builds the thing upside down. This SLA is very accurate. It is very detailed, but again, your trade-off is that it takes a lot of time, and since it's resin, it smells a little funky. You may have to get some ventilation with that. With FDM, which is just our regular 3D printers, they're quicker. There's not odor with that process, but again, it's your balancing out. If you want really small, detailed model pieces, SLA may be good for you. If you just want something done and very quick, FDM may do it, but it may not be at the quality of SLA. So looking at that, I'm not going to stick it in presentation mode. This is supposed to be a gift, but it's not going to work. It's just going to lay plastic on top of each other. This is kind of an over exaggeration. It may not be that thick, but it'll lay it on the print bed. That filament's going to cool immediately, and then that's another solid surface for the next layer of filament to go on top of. And that's, again, I'm not going to put it in presentation mode, but it's supposed to be an animation. But the print bed comes over top. It's building up particular layers from the resin. There's a light source that exists here at the bottom and shoots whatever design is for that particular layer and builds on top of it. And just talking about print quality, you can kind of see the difference here. On the left is your FDM. You can see the layers that do exist there. And on the right is your SLA. It looks very detailed, looks very good, like a very finished product. And it really depends on what you want in terms of your application of 3D printers. If you just want something for knickknacks and it's cool, maybe an FDM is good for you. If you want it for modeling, painting, maybe it's a business, you're going to sell that stuff, SLA may be the way to go for you. The one advantage and disadvantage is that with FDM, the part is much stronger than if it was made SLA. So yes, this is a gear or something that may go into a machine, but I would maybe not recommend using that for some sort of mechanical purpose because it will break. They've done stress tests, they've printed out bolts, and this is not good. The SLA is not good as an actual bolt. The FDM is more fused together, it's much stronger than the SLA. So, again, advantages, disadvantages with that. Types of filament, since we are focusing on FDM, there are the regular ones that you may have heard before, PLA or ABS. There's advantages and disadvantages with that. Lego is actually made out of ABS, I believe, but it's not made out of a 3D printer because you would be able to see the lines. There's some things that you can get as well, transparent depending on what you want. There's flexible stuff, so even when it's printed, like I'll have my Yoda person here, not very flexible because it's not that type of quality. An example is you can print the phone cases that are very flexible with that filament, and you would be able to bend it and it kind of form around your phone. There's stuff that's infused with wood, metal, and magnetic. Use it for whatever purposes that is. Conductive, so if you're wanting to make circuits or you're wanting to make something regarding a lamp, you want to print something thin and make it conductive. I don't know, there's a lot of stuff that you can do with that. And then glow in the dark. There's a few other things, specialty filaments. What we have here in the Digital Learning Lab is what's called Engine, and it's literally like a PLA or an ABS. And we have wood, and then we have metal. Those are the ones that we have here at the Digital Learning Lab. So for those that are really interested in seeing, like, getting this for yourself, as a reminder, actually, let me let you know this. We have 3 of these 3D printers here that are the Lulz bots, which we'll talk about here in a minute, that are free for anyone to use, students, faculty, staff. So it's not like you have to go out and purchase something unless you want it for yourself. But just do know that we are a free resource to you if you want to experiment with this and print something out for yourself. You can get pretty pricey with 3D printers. Entry level, and you're gonna hear it from different people that the range value is a little bit different. But entry level is roughly between 150 to 400. You can get a decent quality printer for like $200. This Creality that's here on the right hand side is a very decent printer for like $189. A lot of people use it. Entry level gets you in the door if you're just wanting to make things for a hobby. Enthusiast is like $400 to $1,500. There's the MakerBot, which is what we have one of these over here, and I'll move the camera eventually for that. And then Formlabs, and then you can get super expensive if you really want to. It's $1,500 and above. This Ultimaker can go to $8,000. Our Lulz bot is about $3,000, and then there are commercial grade professional ones that are very, very large. Do more than we would ever want to do at Catawba College, but they do that for their company and organization. So when you buy a 3D printer, there are some things to look at um, that may not exist on particular models, but standard, there's going to be some sort of print display that you can engage with. It may be touchscreen, it may be not, it may be a button. Ours is literally a button and a spin knob. You're going to have an extruder, which is basically the piece that extrudes the hot um, filament, and then it cools down. Filament's going to be somewhere on your machine. This one's on the right. You have your print bed, is which it's going to be printed on, and it's going to be building up. And then here on the right, it's very specific on what that extruder is. There's the clamp. There's a lot of specific things that are going on. You just need to know that it heats up your filament and puts it out onto the print bed. And there's a lot of things going on to make sure that the heated filament doesn't go back in and clog things. So the slicing software we'll get to specifically, we're going to use Cura as an example. This is where you can do a lot of the detailed work and make changes and change your options. I'll pull that up real quick. Make sure that pulls up before I start talking about it. There it is. Okay. So some 3D printers come with its own software. Cura is very popular. There's another 3D slicer that's out there. But again, just to reiterate, is it's a program that makes your 3D model into instructions. It gives you code so that the 3D printer can read it and then be able to print that. What you would be able to do with this, sometimes it'll give you a test print. This was the test print for the Lullspot Taz that's over here. It prints out this wonderful looking octopus. And from that test print, you can see if things need to be changed. You need to change something physically that's actually on the 3D printer. You can change some settings here. But what you're able to do is move this where you need to. Say you're doing multiple prints. You're able to scale it up. Let's say I actually want it bigger. Very large octopus. I can make a very small octopus. Just know that some changes that you make, the details may not come out. I can rotate. I can mirror things. And then I'm going to actually undo that so we can see it one more time. But just showing you what the slicing software does, I'm going to put this in layer view. And what it does is it generates the code. So if I'm looking over here, it's going to print 110 layers to get this octopus. It also will tell you on the right hand side how much time that's roughly going to take, and that's going to take 1 hour and 4 minutes based off of the settings that you have. And what I can go now is slide through the layers and see how that's actually going to print with each layer if I need to change some things before the print starts. You can set your own profile. Say I want it to go high speed. I just want this thing to go really fast, get it done. Quality may not be good, but you'll see that the time actually goes less than 1 hour and 4 minutes. I can go into high detail, high quality, which it'll take its time. It'll probably be more than 1 hour, hour and 26 minutes. There's things called infill, which I'm going through these steps real quick. There's nothing in the middle, so it's going to print it hollow. But for things to work, it's good to have some sort of support so it can print across it. If it just prints out into a void, your filament's just going to sag and not connect to anything. And now you can see that there is some type of infill here as I make a large mistake with my item. There we go. Doesn't like that. Now you can see that there's infill coming in here with that. If it needs supports, you'll generate it, and then you can just send it to the printer, and it's going to go about its day printing out everything. Things to know if you're printing things. Again, it's not a magical thing that just works. You're going to need supports. Anything that's overhanging more than 45 degrees is going to need a support. So this is just an example of where it starts. 50 degrees, it's pretty good. 45, you start to see some quality issues at the bottom because it has nothing to attach to. And then you start to get this droopy effect to a point it may not work. Here's the example of the supports. Oh, that's not it. There are the examples of the supports that it has to print. Making sure that it comes up on the stream before I keep going. There it is. So there's the supports that it will have to print so it can print things that are floating up in the air. Mess with that. Also, the second thing is that you see that there's infill. Infill adds more time to your 3D print, but it makes it stronger. If you're wanting something very quick, maybe less of an infill. If you want to make sure that it prints quality for every single layer, you may want to put more infill. So 3D prints are not completely solid. If they were to be completely solid, this would take a very, very long time to print. But depending on what you want, you can do that. And here's the thing that I'm going to reiterate again is that there is some post-processing, is that when you print something, you may have to do something with it for it to be finished. Like I was showing you the supports, you're going to have to take those things off. There are 3D printers that have dual nozzles, and one prints your filament, and one type prints a different type of filament, like what's here, PVA, that's dissolvable. So you can put that in warm water and have it cycle through, and it'll actually dissolve that. So instead of you having to pull apart with tweezers and pliers, you can actually have that thing dissolve, and you don't have to worry about potentially breaking it, which is really nice. Also, if you're not a big fan of seeing the lines, you can smooth it out on your own as well. You can do wet sanding. You can take a piece of sandpaper, you can wet sand it until it's smooth, and it looks like you have a more finished product, which is something that, again, you can do on your own if you want to. Also, depending on how large it is, we have like a guitar body that's here. You may have to print it in several pieces. I love this thing. It's so great. So this is Thor's hammer for hopefully people that know about that. This is way too large for the 3D printer. This has had to been sliced up before it was printed in about 5 pieces, and then glued together. Uh, I'm assuming this is paint. So yeah, you can go crazy with the paint, and that's where the SLA printer is really, really good because it's a nice smooth surface, and there's more detail, and you can paint over that. But you're still going to see the lines here unless you do a lot of coating. And then the last thing I'll leave you with is that there is just a little bit of maintenance with 3D printers. Some 3D printers that you buy, you have to put together. So as an example, I'll move this. I hope that shows up. Let me know. Like the one on the right, you buy it, it's there. That's the MakerBot replicator. It just exists. You don't have to do anything with it. The one on the left, our Lulzbot Taz, we have to put together. There's extruded aluminum stuff, but there's a lot of instructions with it. The free one, like the Creality, that's not the free one. The one that's like about $200, which is Creality, you have to put together. You put with Allen wrenches and whatnot, and then you throw a test print and then change some things if something's not working. But you would need some pliers just to tighten some things, grease for the axis if it has any of those specific pieces, cloth to wipe things down, and then isopropyl alcohol, kind of a mixture to clean the build plate depending on what type of build plate that you do have. And the last thing is that you definitely want to make sure that the build plate is level, because if it is not, you're not going to get a very high quality print. If one side is higher than the other, that side's not going to print, and then it's eventually going to get to a part where it's level, and then as it moves across the bed, it's not going to have enough space between the nozzle and the print bed, and it's not going to get anything. So here on the right, too high, it's literally, there's too much gap, and it's just laying it across the print bed, and it's not really adhering to the print bed. The middle section is, again, just right, and then the other one is too low, which basically is you've given it no space, so it may start to clog up the nozzle or not have anything come out of it at all. Questions about 3D printing? What we can do is we've got some 3D prints happening upstairs. If you want to, after the stream, we can go and look at it. If not, that's completely fine. But this is the time for any questions or just to have general chat about 3D printing or my life or, whatever. If the extruder or tube gets clogged, how would I change the extruder or the tube out? What do you mean by tube?
Well, how deep are you clogged? I really.
So you would have to heat if your nozzle gets clogged up, you would have to heat it up so that you can extrude the filament out. It may be to a point where the nozzle can't get hot enough and the plastic is so hardened onto the nozzle that you're just going to have to like peel it off with a pair of pliers. But if you can get it to a high enough temperature where it melts that filament, then you would be able to clean it off with a cloth or some sort of scrubbing wire brush from that point. I think that's the answer to that question.
What's been the like most complex thing you guys have printed?
Most complex thing printed?
I mean, the Mjolnir is pretty complex.
The what?
The Thor's hammer looks
Yeah,
complex.
it really, in my opinion, complex is related to possibly like how many supports exist, like that.
Oh, yeah.
Like that's really difficult. Like if one thing goes wrong, the 3D printer is not, if it doesn't print a layer correctly, it doesn't have that next layer to print on, and it's going to mess up the entire thing. So there's a lot of variables. If one thing goes wrong, that whole print's going wrong, and it's like 12 hours, and you got to start it again. Um, this looks nice and complicated, but it's not really. There are a lot of flat edges to this. Depending on how you print it, like it just looks rad and sweet, but it's actually quite simple. There's just some intricate detail that's here. What have you seen any sweet things, super complicated things that have been printed ever here?
Not here, no.
Mm-hmm.
I've seen people like on YouTube and stuff like that, like using regular 3D printers, like, or not regular 3D printers to print like they. I saw somebody like print a full on gun out and stuff like that, individual pieces and put it all together.
Does anybody know Adam Savage?
Yeah.
From Mythbusters? He's got that Adam Savage tested stuff, and he's got his own YouTube channel, and it's like a business now. He's got like other people that do reviews on 3D printers, and this one guy has printed some sort of ray gun from Star Trek or something. I don't know, but it's the most complicated thing, and it's not really meant to be printed. There's a lot of internal parts. I think one of the most complicated things is that you've built a model within the model, and it somehow has to print that model, build support within the model, then build that solid on top of the support that's within another model. And then you somehow, depending on how you printed it, have to either accept the fact that you're not going to be able to get that support off, or you've built such little support that you can shake it violently and then detach it. Like that you can build a die. Like I can build a die that's hollow in the inside, and then model a small ball within it, and it builds a small support to print that ball, and then I can like slam it, and then it's got that sound to it now because now it's moving. So there's a lot of I don't know, this works. So printed separately. I think what's interesting is when you start seeing models that are printed connected, like it's really good at printing chains that are already connected, and then you just rip it off and it just works. It's already still connected. You don't have to go back and try to reconnect things. You can angle things so that it prints without supports, like a specific angle. Instead of, say, printing it flat, it can go at an angle. So I don't know. Most of mine has been classroom experience in middle school and high school before I came here. So the creativity and imagination was very limited to basketball logos and stuff like that. So we're starting to see some more advanced things happening here. But I mean, the possibilities is endless. But with an SLA printer, you can almost print anything because it prints it upside down and it does it in a format that it's not necessarily relying on the solid to be there for it to happen. I don't know how to describe it, but um, Erin, who's in theater arts, she does little characters with SLA, and they're like very detailed. You would not get that detail out of one of these printers, and she does the painting and everything. It's great.
So you can sand like anything that's printed, or just like these ones specifically.
Ask that question one more time.
So sanding.
Yes. To smooth it?
Yeah.
Mhm.
So you could get like a similar level of detail.
You can get close. You took like detailed like to an SLA in a way.
Yeah.
Yeah, you can get close, but there's just some things that you're not going to be able to do. There's going to be really, like if Yoda was really accurate and not like a low poly thing. There's just things that if you sand it, you're just going to sand that detail away.
Yeah.
It's just going to be very difficult. But with this, you could make this look a whole lot better by sanding that. The thing is, you have to keep in mind, and this is something that I didn't bring up, is if you do those infills where it's kind of hollow in the middle, you only have so much thickness to work with before you hit on the inside. So you can set the settings in your Cura slicing software so that you make it thicker, so that you can have more to work with. So it really depends. Some people just like the lines. You know, they want people to know that that was printed. I didn't buy that thing. Like I made that, or a machine made that. But I like seeing the lines and seeing the process. It's like looking at a tree and the growth of a tree in a way. So yeah.
That's really cool though. I mean, like I wouldn't think you could get this level of detail.
That's very
like,
good.
Is, like, detailed.
You may not be able to see that within like one of the $200 printers that kind of exist. Again, it depends on what you're going for.
Yeah. That's really cool.
What is this? What do you think about the organ printing filament? Organ printing filament. I don't know what that filament is out of.
Oh yeah.
Specifically, and I know they sometimes use a different process for organs where it's covered in some sort of sand. I don't know much about that, but don't think that you can get by with the healthcare system by printing out your own stuff for your own body off of a 3D. But people have made like braces out of the 3D printers that are formed to your hand. You can 3D scan your hand, your arm, or something, and then you can model that around it and print something that's customizable to you. So you gotta use money to save money, I guess. I don't know.
Yeah.
Does Blue Cross Blue Shield cover 3D printing? I
don't think they cover healthcare, much less.
Any other questions from the people online? I'm about to end the stream. I am a high school 3D printing club president, and I'm thinking of going into that field. Is there any tips from a professional?
Like profession, like
a professional.
Oh.
I'm a perfectionist.
Oh yeah.
But not a professional.
Oh.
By no means. 3D printing club president getting into the field. Do you mean the field of 3D printing like in college or a future education? Because if that's the case, you need to go into engineering. Or if you want to teach this, go into technology education, which is what I did.
Is the hammer like two pieces?
So
Like
you
multiple
this is
pieces?
slice. So this is one piece, two piece, 3 and 4 and 5.
Oh, okay.
You could probably again you'd have to figure out what's the best way to print it. Like I can take that and probably print it all in one go.
Mm-hmm.
If the printer was large enough, there would just be some things that would probably get sacrificed since this is hanging off. It would
Yeah.
probably have to build a support on every single one of these. Wouldn't be ideal. So you can kind of see that this was the bottom.
Mm-hmm.
These pieces got printed this way.
Oh, okay.
And then I'm assuming this got printed. Maybe this was the flat bottom on both sides, and then they glued those together. But yeah,
How well does like the paint adhere?
paint. Well, with most things, sanding it is good to do first.
Yeah.
But it does a decent job of printing it because it does well on the resin. It does okay here. I just don't remember what type of paint they used for this, acrylic or some other type of specialty paint.
I would assume acrylic because it's like plastic based too, so it would probably like stick a little bit better. But,
Yeah. And then you can put a clear coat over top of it as well and make that thing shine.
Yeah.
If Thor's hammer shines,
Yeah.
you gotta be accurate and detailed.
That's very cool. I enjoyed this.
Yeah.
So-
I'll have to.
But-
Yeah.
Nothing about it.
I know. I think
know
I
a lot
heard.
more now.
I heard something about us having like a digital lab, but I didn't know very much about like what all you had. So I'll have to stop by sometime.
Yeah, it's upstairs. Like if you want to go on the way out, it's upstairs. That's where I live.
Yeah.
But we have 3 of those 3D printers there and a ton of other things. And if you don't know how to do something, I'm in there. Student workers are in there to help out with whatever you need. If they don't know, they'll defer to me and help you out and do some things. A lot of the students come up like, I got some business ideas, and some people have had jewelry companies that they do, and they want to kind of expand on that. So this is a very good way of doing it, like rapid prototyping something before you even make it for real is cool. So if you haven't already, sign up with MakerBot for updates because they're constantly hosting virtual workshops with instructors and professionals to explore and explain the field and 3D printing possibilities. Yeah, MakerBot's a really good company, and you can go on YouTube. YouTube is your friend for everything, but they're always exploring new capabilities of 3D printing out there. So for people that are on the stream, I'm ending it. Thanks for coming out, and we'll see you on the next wonderful workshop next week, Tuesday, 11 to 12, intro to Tinkercad if you want to learn how to model. If anybody wants to learn how to do that. Thanks.